Sorry, don't mean, like, even my social skills are a little off. I don't mean that as an overrun. I know since I said it, it was kind of like cutting a student off, and that's not how I meant it. That's a great introduction for a video too, by the way. Right there. That's just, I don't know, exemplary. That should be used as an example of how not to start a video. That would be another addition you could add. Some bodily noises. All right, so I think this should be a video in and of itself. I'm going to stop this one and put that up to YouTube. Check it out. There's something called the Go blog. So you could go to Google and you could search for the Golang blog. And this is like the place you want to go for, you've got effective Go, you've got the Go spec, and then you have Caleb's book, right? So we talked about resources, and you should know what I'm talking about when I say Caleb's book, the Golang book, Golang-book. And then there's also the book, which you have access to through Blackboard, which is awesome. So you should totally be reading that and save chapters 2 and 7 to the end. And if you don't know what I'm talking about, just look on the front page of Blackboard. You have a link to the book right there. You should be reading that. Awesomeness, man. And this one, Caleb's book, Golang book. And then Effective Go is another place you look, but this gets a little bit more like, haiku, a little bit denser reading, but also very valuable sometimes. And then also the language spec, again, haiku-like, dense reading, but also really valuable at times. But another really valuable resource, the reason I'm spieling all this, is the Go programming blog. So this is like, fantastic. And this is the place you want to look for definitive information. In particular, you have the blog index right here. And so I was like, hey, is a map a pointer? Like, what is the data structure of a map? So just like a slice is really, a pointer to an underlying array, and the slice has the pointer to the underlying array, the length, and the capacity. Those are the three things that sort of make up the slice. That's the header, right? And so that's really only 24 bytes that I'm passing around. 8 bytes to store a memory address where the array is, 8 bytes to store length, 8 bytes to store capacity. 24 bytes. So when I pass the slice around, cool, right? And you want to think about types. Like what are types like? How do we use types? And do I take the address and pass a pointer or not? Am I passing the whole data structure? Like, would I take the address of a slice? Yes or no? Like I have one function, I got another function, and I want to pass, a slice and have it be changed and then have access to the changed slice in the original function, right? Do I pass a pointer so that I'm accessing the memory on that slice? Do I pass, a pointer to the slice? No. No. Because a slice is a reference type, right? And so as, I'm just passing, even if it gets its own new, like I pass, it gets its own copy in the new function, the copy it has is the address pointing to the underlying array where all the data is stored. So as I change that, it changes the underlying array. And I was wondering, is a map the same way? And I say that with 92% certainty about a slice. We're going to prove it here in a second. I haven't proved it yet myself, right? But I say that with 92% certainty. So we'll test it out. And that's how you answer questions. You learn things. You're like, okay, I kind of understand that. And you're like, wait a minute. I remember Bill Kennedy or Todd McLeod talking about this, whoever you learned it from. And is it true in this case? Let me test it. Because when the book and the bird differ, I'm doing this so much better than Fresno State did. At Fresno State, I sounded like I had just gotten off a train drinking, Thunderbird all night. When the book and the bird differ, who do you want to believe? You want to believe the bird, right? So read the theory, but then run the code and see what happens. And see if you can prove it with the code. So the Go blog, a great resource. And I came in here because I wanted to learn about maps. And so I did, Control F, and in February 6, 2013, they talked about maps. And the person who wrote this was Andrew Gerond, right? And if you look up who Andrew Gerond, or whatever his name is, if you look up who he is, Golang, right? He's like one of the people, I think, who works at Google. I don't know. 2 recent Go talks, the Go blog, one by him. But let's see what he does, because I'm not totally sure. I work on the Go programming language at Google. Right? Like, awesome. I want to know, if this guy has something to say, I want to know about it. I want to know how he says it. And, when I look at talks, okay, I believe, I could put faith. I could have credibility. You know, he has credibility, right? I could have faith in what he tells me. Reading anything online out in the wild, you don't know who wrote it or who made this video or if it's any good. I should be suspect. I'm not an engineer working on the Google, at Google on the Go language team. This man, however, right, if he says something, you have really high certainty that, okay, this is the way it is. And so anyhow, trust your sources, because on the internet, anybody could be a dog, including myself. And so, just looking at what he had to say about maps, okay, really awesome. I haven't finished reading this article, but I want to. And so here's an assignment. Okay, we don't explicitly do a lot. We haven't done a lot of assignments. I'm giving this to you, but I want you all to choose some article in the Go blog, whatever it is, and then put together like a little bit of a summary of that article. Come in and tell us about it. And so we'll do that like a week from Thursday. You will have each of you come up and say, hey, this is the article I chose, and these are some of the main points that stood out to me. I read this one, and I learned this thing. So you don't have to teach it all to us. You could teach it to us if you want, but show us the little pieces you learned, right? Hey, I learned this about it, or I learned that about it. I read this article. So is that clear? You can read a Go blog article, and then you're going to give like a little presentation to the class, like what did you learn from it? Which one did you choose? What did you learn from it? Maybe teach us a thing or two. So the other thing that you saw at the Go blog here was they had, hey, this is the most recent post, and here's a conference that was on, right? And you could see Andrew Gironde, okay, cool, he has a video. I want to watch that. What did he have to say about it? But when I looked down here, I saw this one, Understanding Memory Allocation in Go by Dean Elbaz. I don't know who that dude is, right? Like, let's search for Dean Elbaz. Golang. Speakers at the conference, and then here's his talk, and then Dean Elbaz on GitHub, and Golang UK 2015, and then maybe this is him, retweeted UK, so yeah, that looks like the guy, right, but it doesn't really say anything about where he works or what he does. And so I was watching his presentation, and there's some things that, like, from what I've already learned, I'm like, I don't know. So just trust your sources, right? And Andrew Gironde, that'd be something. But anyhow, that's part of learning, trying to figure out who to learn from. So let's check that thing out with. First, I'll show you the thing with the maps that I was playing with, just because I find it interesting. And then we'll get back on track. So passing a map. So here's a map, right? And I have it in func main. And then I say, okay, I want to add an entry. And I created a function add entry, right? And I passed into that, right? That function takes a map with a string and a string, a key of a string and a value of a string, right? Key value, map. And then I'm going to add an entry to the map. So the key will be Harleen, and the entry will be Howdy. And I'm going to print the map right here that is inside this function. And then I'm going to come back here and print this map and see if I can access Harleen, right? So if that's possible, then the map is a reference type. And I'm not sure I'm using that word correctly, but I'm pretty sure I am. Meaning it's referencing some underlying data structure. And when I'm passing my map around, I'm passing a reference to that underlying data structure. And so here, right, this M right there is referencing the same underlying data structure that is being referenced by this. And when you pass values to functions, right, normally the function gets its own copy. Okay, so you pass something into a function and it gets its own copy. And so let's take a look at that too. I'm kind of in like learning territory for me also right here. So this is just like an exploration, and let's just understand how this works. So I'm going to go into I think this should actually be like its own little thing inside functions. So we'll do functions, and then 26, and we'll do, passing args, and what that looks like. And so then we'll do 1, and we'll do an int, an int, an int, an int. Sure. And we could do we'll do main I'll cancel that. I'm just going to copy this one up here and put it there. And so let's just do so age colon equals 44. Change age. Well, let's call it change actually. Change me. So we'll pass age into there, and this is going to receive, you know, let's call it x int, and then we'll say x format.println x, and we'll do x is equal to, you know, 24. That's the body I'd like, but I want the wisdom of 44. And then we'll print x, and then up here we'll print x. Okay, and let's run that. And that is inside functions, which is 22. And no, 21. And then it's inside 26 and 01. How many people, show hands, find this somewhat interesting? Why? It's kind of like that scientific approach, right? Like, I have a question. Can I do an experiment? What is the result? And it's also the essence of all good stories, all good books, all good movies, right? It's like, hey, there's a question. How's it going to turn out? So what do you think is going to print right here? Sorry, age. That needs to be age. What do you think is going to print right here? That line. What will that answer be? I think it's 44. 44, 24, 44. Right, so this one here, whoa. This one here is 44. This one here is 24. And this one here is 44. So this got its own copy, right? It changed the copy and it never impacted that because the scope of that is here, right? That's this scope and that's this scope. How could we fix this where these two functions would have been able to change the same variable? We could have given the variable package scope, right? And do stuff in it here and do stuff in it here, and both packages have access to that scope. Or we could have created some sort of closure, you know, which is kind of the same idea, right? So here's also something interesting. What is the address? And I've gone down this road before and it hasn't turned out in a way that was intellectually satisfying to me. Just forewarning, we'll see what happens. Isn't that interesting? So we're talking about here, the first time it prints is that address, this is this address, and then this is intellectually satisfying to me. Right? So we can see that we're actually talking about different memory locations where, you know, a variable is being stored, a value is being stored. So the x has its own memory location and age has its own memory location.
Print the address to age before you run the function. Just after you assign 44 to the age.
Oh, right here? Right there?
Yeah, right there. Do the same thing there.
So we've got new ones. Here's the first one.
Okay.
And here are the next two. And then here is, so that makes sense.
That makes more sense, yeah.
Isn't that cool? I love it. Exploring, learning. So that's with an int. I imagine float's going to be the same, but let's try string. All right, so we want this to be a string, so name, Todd. And now we'll print name, name, name. And we'll pass in, here we'll have x and it'll be a string. And we're going to change it to, well, I really like my son's name, Oliver. But I total like, now people will be like, okay, if I want to hack Todd, there we go. It's one of the key pieces of information. I don't know, what would I change my name to? You guys, what would you suggest for me? I'll crowdsource it. Did you say Apollo? Okay, I like that. I'm Apollo.
Okay, there you go.
Which is, if you say it quick enough, it sounds a little bit like up all night. Apollo. Up all night. Which, if you've been up all night, you say up all night, kind of like Apollo. All right, so I say first of all, right, let's run it the first way. And let's do this string, what do I call it? Address. And that should be 4. So we'll take out these little ampersands. And change. Todd, Todd, Apollo, Todd. So when I pass that into a function, right? Sorry, different scopes. And now let's do the addresses. And that's this is going to be Todd, Todd, Apollo, Apollo. I think Apollo is a nice name, actually. I don't know. I'd have to sit with it.
Wait, are you sure that's what it printed?
Yeah, I thought it was 3 times.
It was 3
Oh, really?
Yeah, the third one is Todd also.
Oh, there we go. So Todd, Todd, Todd. Yeah, that's right. Correct? Thank you. First, second, third, fourth. All right, perfect. So now let's look at number 4. First, second. It's kind of interesting. Are those the same addresses? Am I in the right spot? We got the same addresses. Wild. But same thing, right? 2 different memory locations. Well, it's interesting because a string is a reference type. If you look at, like, from what I've learned, the underlying data structure, the internals of a string it has you learn 2 things from type. The 2 things you learn from a type are its representation. Is it a string or is it an int? And then you also learn its size, right? And a string has a header, and the header is one of the pieces of the header is a pointer to an underlying array, and the underlying array is is it a slice of bytes? Kind of on learning territory, learning ground here for me myself. I gotta go back and look at my notes on that. But a string being a reference type, but strings are also immutable. You can't change strings. So just like some interesting questions.
So if you wanted to change the name
Yeah.
on the outside without making it a package level variable, can you like return? Can you have the function return it? that'll change it?
Yeah, so you could do so Bob's question is like this. So we could return a string, and we could also say that name is equal to, name is equal to change me, right? So name is going to be the new string that comes back, and we could return x.
Pretty simple.
$300 would be the first time. 320 is that time. 320 is that time. And 300 is this time. And if we print the values, then name. So this is Todd, and then this one is Todd, and then this one is Apollo, and then this one is Apollo. But that's just, passing a value back. So it'd be kind of interesting then to say the next thing would be like this to play with. I think we're going to have to go back and do int pointer. So we have print out the address, and then pass into here the address. And this is going to take a pointer, a type pointer string. That is part of the type. The star is not an operator. It's part of the type. The type is a pointer to a string. Okay, so it's a memory address that holds a string. That's the type. And now if I change x, if I print x, I'm going to see a memory address. And so this is an operator. I'm saying dereference, like that type. I want the value and I want to set the value. So I could print that, I could print the memory address, and then I could see the dereference. And then I could say, you know what, at this memory address, the value there should be this. Okay. And I don't know if I want to, I could print the memory address again, and I could print the value. The memory address hasn't changed, so that won't tell me anything new. And then I no longer need, okay, this doesn't have the return. So I'm printing the address there, and then here, change me, I'm passing in the address, and then here I'm printing the address, and I'm just going to print the value. How many people find this interesting? Mikey! Kai! I find it interesting. So, first time through, this is the memory address. And then it calls change me and passes in a memory address, and then it prints change me, which, it prints the value that came in, which is a memory address. So this memory address came to that one. And then it prints the value right here, right? And then I say the value at that memory address should now be Apollo. And then I print the memory address. And then I print the value at that memory address. And then I come up here and print line this one. And I print the value. So the first time, here's my memory address, and I pass the memory address there. And then I print the memory address, same memory address, right? And then I print the value there. Okay, that's the value. And then I reassign it, and I print that memory address, same memory address. That's what we expect. And I print the value now, right? And we have, you know, the value's changed. I was thinking I could do multiple selection. That's how you do it. Right, the value's changed. And then I come back up here after I've changed the value and I print the memory address and I print the value. So the memory address is the same all the way through.
So we've gotten around the scope problem by pulling the memory address into the function.
Yeah, passing a memory address. And what's the size of a memory address? It's a byte. I'm pretty sure. Like 82% certainty on that one, 87% certainty. But there's something else going on there with the internal strings being immutable, strings being slices. Like a new array got created beneath the surface, I imagine. Or maybe it's a slice because strings are a slice of bytes. But I think underlying a string. So you know what I do at this point in the question? Golang log index string. Text normalization, strings, bytes, runes, and characters, array slices and strings, and mechanics of a pen. Like both these are going to give me a lot of information. The internals, how are things working? Right? It's like, oh, okay, cool. So maybe that'd be one of the articles that one of y'all reads. You know, those two articles, October and September 2013. And let me know which articles you're reading. Like, send me a link. Email me a link. You all have my email address? I'll give it to you. Yeah? Yeah, all right, I'll give it to you in class. Not that you can't just see it right here. Todd McLeod at Gmail. I don't know why I'm like, sometimes I go secretive, and it's like, well, so many other times I'm not. I'm like not wanting to say my email address, and there it is showing on the whole screen.
Do you use your city college?
No, not. I do. I check it, but the Gmail is the best way to reach me. So send me a link to whichever article you're reading. So that's kind of interesting. You think we'd see the same thing with the int? Do you guys want to go through that with the int? Yes? All right, so let me do the int, and that would mean that becomes 3. This is going to be 7, and this one's going to be 6, and this one's going to be... I just find it like totally cool that like, you know, I could kind of see the memory addresses. It's like, oh my gosh. It's not just a theory, you know, it's like, there they are. And I think I'll just bring that one up here and make it 3.
Can you do it in other programs? Other programming language?
Not only can you do it in other programming languages, you could do dangerous things in other programming languages. Like, I don't totally understand it because I never took C programming, but there's ways that you could try to address memory that you shouldn't be addressing because it's being used somewhere else. You could just say, hey, at this memory address, do something. And, you know, that could create problems. So Go protects you from the stupid stuff I've heard, but I never took C. I never studied computer science. I used to just be a boxer, and then I decided I wanted to learn programming. Sorry. I used to fight karate, compete when I was young. I did. Before MMA and all that stuff. Just high school. All right, so here we want to do this as an int. So let's change that to age. And we'll change this to 44. And we'll change this to 24. And I think that's going to be good. And let's run it. And by the way, if you're watching this video and you're like, how did you select all the variables at once? That's one of the keyboard shortcuts. You could find default key map reference in WebStorm. And Command Control G. That's how you do that on the Mac. And then go run main. So something blew up. Cannot use age as...
Pointer on X, so that what you
So here we got age is 44. Print line the address. Change me, pass in the age. That needs to be int. Am I in 3? I'm in 3 int pointer, 3 int pointer. Can I use age? Did it save? There we go. I didn't save it. Well, automatically saves, but I just went too fast for it. So that's that one. 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 So same deal, right, with age. So let's take a look at a map. Let's do a map. So now data, or we'll call it M. So this is age. Wasn't it? No, it's name. What? I'm all the way up there. Name. Naeem. And we'll call it M for map. And when you make a map, what I was learning today for maps is that you could, variable M is a map of string keys to init values. Maps types are reference types, like pointers or slices. Ooh, right? That's interesting right there. Map types are reference types, like pointers or slices. So just like we saw those pointers were references to memory addresses, so are maps and slices. So we don't need to take the address, you know, because that's redundant. Does that make sense? It's already just an address that's pointing to a data structure elsewhere. So maps are reference types like pointers and slices. And so the value of M above is nil. Huh? How did he get to that? The value of M above is nil. So when you use var, and we've talked about one of the things I've learned from Bill Kennedy is when you declare, assign, initialize, right? So use the shorthand notation all the time. Unless you want something to be initialized to a 0 value, then use var, right? So when you use var, it initializes to the 0 value. And 0 value, you could Google that. You could search for Golang 0 value. And it's going to take you to like the language spec. And then you could come in here and search for 0. And then here's 0 value. And then here it says, hey, the 0 value is false for Boolean, 0 for integers, 0, 0 for floats, that for strings, and nil for pointers, functions, interfaces, slices, channels, and maps. Whoa. Right? Whoa. So the 0 value, all you got to remember is false Boolean, 0 integers, 0, 0 floats, and empty string for strings, and then nil for everything else: pointers, functions, interfaces, slices, channels, and maps. And so
does that mean it hasn't assigned a memory reference location?
Okay, so
It's going to be that, but it just hasn't assigned it yet.
nil. It doesn't point to an initialized map, so it's not initialized. So initialization, I guess, maybe is like. Initialization to me means I've declared and I've assigned, right? So, so maybe initialization, a nil map behaves like an empty map when reading, but attempts to write to nil map will cause a runtime panic. Don't do that, right? So I'm sure it probably, let's take a look. Let's build it up, okay? Let's take a look. So step 1. And this one needs to go to some other number. Step 1 is just going to be var m right, var m map string int. Just copy that over. And I've got a couple of errors. Why am I showing an error with font? My editor. What's wrong with that? And it would be an error if I tried to run it. What's wrong with font and M?
You haven't used.
I haven't used either. And when you don't use something in Go, it's an error. Why did you tell me to drive downtown to meet you at the bar and you're not there? Don't tell me to do something if it's not going to be used. Right? Don't tell me to go meet you somewhere if you're not going to be there. That's an error. So format.println. I don't know if that was the best analogy. What's with the drinking? No more drinking for Todd. You thought it was a good analogy, Bob?
Yeah, that was funny.
All right, so now if I try to print that out, what am I going to see? Who's a gambling person?
Oh, okay, what's the question? What's that going to be?
What am I going to see when I print that out? Because we know var assigns it to 0 value, and the 0 value of map is nil. We just read something in the documentation about how it will act with reads, but don't try to write to it, right? That's what it said. It'll throw a panic. So let's just see. I have no idea what's going to happen. Help us. Map. Right? And then what about if, I'm going to change this to, I don't know, I guess, I'm going to change it to int. I don't know why I'm doing that. I'll do string int. And so let's say I'm storing people's ages and their name is the key. Okay? So now what's going to happen? Well, first of all, what's going to happen now? Will I get an address where that map is at? Nope. Wow, that's interesting. Just said, hey, this is, I don't know if there's something else in there. What about this? Map M, what's Bob's age? Right? Like, I've never put that key in there. And the way maps are set up is if you ask for a key that doesn't exist, it should return at 0 value. So I'm thinking we'll get 0 back because the 0 value of int is 0. 0. And I don't know, just kind of thinking about things. What about where is that 0 stored? Cannot take the address of mbob. What about if Bob actually existed? Make you the same age as me. I think this is going to blow up because when reading, it behaves like an empty map, but attempts to write to a nil map will cause a runtime panic. Don't do that.
So you use the make function.
Cannot take the address of mbob. Let's get all this stuff out. Panic. Assignment to entry in nil map. So don't ever use var m, apparently, right? Because you can't ever write to it. So what would be the point?
So it just knows what it knows the type, but there's nothing there. There's nothing saved anywhere. Is that what's happening? It's just returning the type, basically.
Yeah. All right, so let's look at this one. Stein 9. Do you want another Stein of beer? 9. You want 9 Steins? No, Einstein. You know Einstein's named one beer? Did you guys know that? His name is one beer. Einstein. It's one mug, but Stein is often a beer mug in Germany. Based upon that assumption, I decided to drink a beer last night, seeing if it would take me to Einstein's level. It didn't work. It actually regressed me. So here we're going to use copy that. This one. M : equal make and map string. And then we could print, dun, and that should all work. Map 44. Can we do this now? Just out of curiosity, like where is that stored? I don't think so.
So was there any point to using var?
Not for maps that I could see. Yeah.
I mean, can you use it to start and then do something with it later that fixes it, or is it just not any point in using that structure?
I don't know. I don't know for maps, right? But I mean, for a string, an int, a float, sure, because we get the 0 value, and we could use that. But you get nil when you do it for slices, pointers, maps. So, you know, all this is building up to being able to do this deal. So we did this thing with So I have a map. I can print that map. I can see the address of that map. It's just going to be like that funny looking thing, right? Actually, I don't need to do that. Let's do this one, and I'm going to run change me, and then I'm going to print out my map, and we'll give it some key. And then down here, we're taking in this. No pointer. And we can print that map. And we don't need that. And then we could change that map. And then I don't think we need to print that, but I guess we could. Let's do that, just keep it clear. Is this clear? Right, that won't exist if it didn't persist, so we don't need to do anything. I think that might be a little bit clearer. So the first time I print the map, right here, that's what I get. Just an empty map. I guess we don't even need that line. That shows it, right? So I didn't have to, use a, I mean, it is, like the documentation says, maps are reference types like pointers and slices. And so if I did the same thing with a slice, we're going to see the exact same functionality. And so we could use make for a slice. Or we could just do, what is it, like this? And the length and the capacity, right? And then we could change, pass that in, and here it's going to take in a slice of strings. And so X, append X, Todd, Rio. And then print line M. Let's make it 5 and 10 and 20. I don't know. Don't want my computer to have to work too much. Empty slice. What happened? It's not what I expected.
Scope?
Huh?
Scope problem?
It's got 25 spaces in there, I think, or 10 spaces. Change me. Pass that in. So let's just check effective go. No, sorry, go by example. And slices. And make slice string 3, or make slice string length s, or make. He doesn't have an example of length and capacity. So if we look at the spec, that's long. Slice. Make slice of t length capacity, so that's right. And So we make it, and then what happens if we do this? M, and then that. Now let's run it. Kind of interesting. And then change me X slice of strings. Could I do this?
Let me print something inside the function. Print X and after you append it.
That's a good idea. I got a bunch of stuff starting out there. We're going to start out with nothing. Looks a little better. So what happened, man? I thought slices, map types or reference types like pointers or slices. Interesting that the way the map worked. Slice. What can we do? This? No. But then we'd have to dereference here. That's interesting. So I'm able to do it with pointers. That's a whole lot of pointers. So I'm not quite sure why that works that way. I can reassign. Doesn't like that. Anyhow, it's fun to play with, and that's a really good way to learn. And I got going down that path because I was working on this problem right here, memcache, and data store, Ajax. Where was the problem that even got me going down that road? Here we go. Photoblog unfinished. And I was trying to change some code in there. And I'm passing around a map. And I was like, okay. As I start up here in this function, do you guys want to walk through this and kind of see this code? This isn't complete code, but maybe we could troubleshoot it together. I'll make that the next video.